Section 5.4 is solving equations using the zero-factor property. So now, by this point in sections 5.1 through 5.4, we've learned how to factor, and now we're going to apply our factoring in order to solve equations. So, quadratic equations in one variable are of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a doesn't equal to 0. This is a quadratic equation in standard form. And we're going to talk in later chapters about what the graphs of these look like. The graphs of these are, why am I doing that so much these days? The graphs of these are parabolas, so they look kind of like this, like the squaring function. And that's something we're going to learn more about graphing them and solving equations, solving applications of quadratic functions in chapter 9. But right now we're just going to focus on solving these using the zero-factor property. So if a and b are real numbers with ab equal to 0, then a equals 0 or b equals 0, or both equal 0. Why does this work? Well, let's say I had 0 times 6, that's going to be 0, so that was my a and this is my b. If I have 0 times 0, that's 0, and if I have 7 times 0, this is my ab, that's also 0. So I'm trying to figure out where my x value is going to be 0. So if I've got x plus 6 times 2x minus 3 equals 0, that's a factored form of a quadratic equation. I can solve for x, and I'm going to get two different values of x because I've got two terms. So I have x plus 6 equals 0, and 2x minus 3 equals 0. I'm going to go ahead and solve this. That gives me x is negative 6. I add 3 to both sides. 2x equals 3, x equals 3 halves. So I have x is negative 6 and x equals 3 halves, or my solution is the set of negative 6 and 3 halves. So how do I solve a quadratic equation by factoring? The first thing I'm going to want to do is I'm going to write my equation in standard form. I want to factor my polynomial. We know how to do that. We're going to use the zero-factor property, find solutions, and then always we can check our answers back in the original polynomial. So here I have x squared minus 5 plus 6. So I label my a as 1, b is negative 5, c is 6. And I want to know what are the factors of ac, which is 1 times 6, which is 6, that add up to b, which is negative 5. Well, the factors of 6 that add up to negative 5 are negative 2 times negative 3. So now I have x squared minus 2x minus 3x plus 6 equals 0. This is going to factor. I've got x times x minus 2, negative 3x, and positive 6 have a greatest common factor of negative 3. Remember, we don't like negative leading coefficients. So I get x minus 3 times x minus 2 equals 0. Now I can solve for x. I have x minus 3 equals 0, or x minus 2 equals 0. That gives me x is a positive 3, and x equals 2. So my solutions are when x is 2 and 3. So let's go ahead and solve these three equations by factoring completely. Remember, I've got to get these in standard form first. So I have 2x squared plus 3x minus 2 is 0. And I say, what are the factors of AC, which in this case is 2 times negative 2, which is negative 4, that add up to B, which is 3. Well, some factors of negative 4 that add up to 3 are negative 1 times 4. So I've got 2x squared minus x plus 4x minus 2, and now we factor by grouping. I have my grouping symbols. The greatest common factor of 2x squared and x is x. The greatest common factor of 4x and 2 is 2. So I have x plus 2 times 2x minus 1 equals 0. So that means x plus 2 equals 0, or 2x minus 1 equals 0. That means x is negative 2, or 2x is 1, x is 1 half. So my solutions are when x is negative 2 or 1 half. Let's work through another example. If I have 4x squared minus 20x, this is a binomial. I can pull out the greatest common factor, which is 4x. 4x times x minus 5 equals 0. So I have 4x equals 0, or x minus 5 equals 0. That means x is 0, or x is positive 5. For problem 3, again, let's pull out the greatest common factor. The greatest common factor of 3 and 108 is 3. So I have 3, let me change colors. 3 times x squared minus 36 equals 0. This is one of those special factors. It's the product of a sum and a difference. So I have 3 times x plus 6 times x minus 6. And I set all of my factors equal to 0. Now the 3 equals 0 doesn't really make any sense, so we ignore that. I've got x plus 6 equals 0 and x minus 6 equals 0. So x is negative 6 or x is positive 6. My solution set is x is negative 6 or 6. A couple more examples. If I have 2x squared plus 5x minus 7 equals 0, well, what are the greatest common factors of AC? I don't want this color. AC, which is negative 14, that add up to 5, which is our B. Well, negative 14 factors into a negative 2 times 7, which add up to a positive 5. So 2x squared minus 2x plus 7x minus 7 is 0. And then we go ahead and factor by grouping. 2x times x minus 1 plus 7 times x minus 1 is 0. 2x plus 7 times x minus 1 equals 0 is our fully factored version. So I take each of my factors and set them equal to 0. Subtract 7 from both sides. 2x is negative 7, so x is negative 7 halves. I add 1 to both sides. X is 1. So I have x is the solution set, negative 7 halves, 1. For this last example, I'm going to go ahead and make sure I've got everything on the same side of the equation. My greatest common factor here is x. Well, let's make that a negative x because we don't like negative leading coefficients. So I have negative x times x squared minus x plus 6 equals 0. I then need to factor this. The greatest common factors of AC, which is 6, that add up to B, which is negative 1. Nope, it's a negative 6. Remember, once I pull out that negative, I've got to switch the sign. Factors of negative 6 that add up to negative 1, that's going to be negative 3 times 2. So I have negative x times x minus 3 times x plus 2 is 0. Now I set each of these factors equal to 0 and solve. And because this was a degree 3 equation, I have 3 possible solutions. So I get x is 0, x is 3, or x is a negative 2. Now, you may have noticed I didn't pull apart this middle term and factor by grouping. Well, when my leading coefficient a is 1, I have a shortcut. You may have noticed that it always is going to factor into what adds up to AC. So go back and look at some previous examples and see if you found that little shortcut yourself. But our solution set is negative 2, 0, 3.